Recent news out of Lebanon has caught the attention of security analysts and tech experts alike. Thousands of pagers and walkie-talkies used by Hezbollah members were mysteriously rigged with explosives and detonated remotely. These devices, considered a secure means of communication by Hezbollah, became deadly weapons. What's more intriguing is the sophisticated operation that unfolded, involving multiple layers of supply chain infiltration, technological manipulation, and remote detonation. To understand how this attack was carried out, we need to delve into the technology behind it and how it was used with such devastating precision. While there is speculation about the entities responsible for this operation, our focus will be on the technological mastery involved, from the manipulation of low-tech communication devices to the execution of remote detonations. But before diving into the technical details, let's first explore what pagers are, how they work, and why they're still used in certain environments, especially in the context of secure communication. Pagers may seem like relics of the past, but they continue to serve important roles in specific sectors. In their most basic form, pagers are wireless telecommunications devices that receive and sometimes transmit short messages. Once a staple of the 1980s and 1990s, pagers were often used by doctors, emergency responders, and business professionals. Even though smartphones have largely replaced them, pagers are still valued in certain sectors for their simplicity, long battery life, and ability to function where cell coverage might be unreliable. What makes pagers ideal for organizations like Hezbollah is their relatively low-tech nature, which makes them harder to track than modern smartphones. Pagers rely on radio frequencies to receive messages, and because they don't constantly ping cell towers or Wi-Fi networks like a smartphone, they are less susceptible to surveillance technologies that modern militaries use to intercept communications. The types of pagers that Hezbollah was reportedly using were even more secure. These weren't your typical beepers from the 90s. They had been modified for military-grade secure communication, allowing for the transfer of encrypted messages over vast distances. Unfortunately for Hezbollah, it appears that these very devices were compromised long before they reached their hands. The operation that led to the remote detonation of thousands of pagers and walkie-talkies in Lebanon was no ordinary cyber attack. This event demonstrated a sophisticated blend of old-school espionage and cutting-edge technology, which came together in one of the most highly coordinated sabotage operations in recent years. The sheer complexity of compromising the supply chain, manipulating the devices, and timing the detonation to near perfection suggests the involvement of highly advanced technical capabilities. At the heart of this operation was an understanding of how to infiltrate the supply chain of a clandestine organization like Hezbollah. Pagers and walkie-talkies destined for Hezbollah had to be rigged with explosives without detection at any point along the supply chain. This level of access implies not only superior intelligence capabilities but also a deep understanding of manufacturing and distribution processes. In addition to rigging the devices, the attack required precise coordination. Detonating thousands of devices almost simultaneously across a wide geographic area is an extraordinary technical feat. It suggests the use of sophisticated signaling methods to remotely trigger the explosives, while ensuring that the operation remained undetected until the moment of detonation. Now let's take a look at the technologies that could have been used in pulling off this operation. Several technologies likely played a role, ranging from advanced microelectronics to covert signaling systems. Here's a breakdown of the most likely tools and techniques involved. First, microcontrollers and embedded systems. Each pager or walkie-talkie was probably fitted with a microcontroller, a small but powerful computer chip that can process instructions and trigger events. These microcontrollers were likely embedded with the explosive devices inside the pagers and walkie-talkies. Once the devices were in Hezbollah's possession, the microcontrollers would lie dormant, waiting for a signal to detonate the explosives. Next, GSM or CDMA modules. These communication modules, which are commonly used in mobile phones, could have been installed in the pagers and walkie-talkies to enable remote communication. With a simple GSM or CDMA connection, each device could receive commands over a cellular network, allowing the attackers to send a remote detonation signal at the precise moment of their choosing. Then, GPS and geofencing technology. Geofencing could have been used to ensure that the devices would only detonate within a specific geographical area. By programming the microcontrollers to trigger the explosives only when the devices were inside Hezbollah-controlled territories, the attackers could minimize the risk of premature explosions. Also, remote signal transmission, whether RF or satellite-based. To detonate the devices simultaneously, the attackers likely used radio frequency signals or satellite-based communication systems. This would allow them to send a single signal that would reach thousands of devices simultaneously, triggering the microcontrollers and causing the explosives to detonate. Lastly, explosives miniaturization. Another key technological challenge was fitting explosives into the tiny form factor of a pager or walkie-talkie without raising suspicion. Advances in miniaturized explosives and detonators made this possible. PTN, a common military-grade explosive, is highly potent in small quantities and could have been used in this case. The remote detonation of the pagers was likely the result of meticulous planning and precise execution. Given that Hezbollah's pagers were distributed over a wide area, the attackers would have needed to ensure that each device was triggered simultaneously. Here's a possible scenario. Each pager was fitted with a microcontroller connected to a small explosive charge. These microcontrollers were connected to GSM or CDMA modules, which allowed them to receive messages over a cellular network. When the attackers decided to detonate the pagers, they sent a signal to all the devices at once, likely using a combination of GSM and GPS technologies. The microcontrollers would have been pre-programmed to detonate the explosives only when the devices were in Hezbollah-controlled areas. This could have been accomplished using geofencing technology, which would prevent the explosives from going off in non-targeted regions. Once the signal was received, the microcontrollers activated the detonators, causing the pagers to explode. The use of GSM or CDMA modules would allow the attackers to trigger the explosion with pinpoint accuracy, ensuring that all the devices detonated at almost the exact same time. This level of precision is rare and highlights the technological sophistication behind the attack. While the pagers were rigged to explode using cellular technology, the walkie-talkies used by Hezbollah posed a different challenge. Walkie-talkies rely on radio frequencies for communication, which means they don't have the same cellular capabilities as pagers. However, they still presented a viable target for remote detonation. To rig the walkie-talkies, the attackers likely used a similar method to the pagers, embedding microcontrollers and explosive devices inside each unit. The difference lies in how the signal to detonate was delivered. Instead of using GSM or CDMA signals, the attackers would have used RF signals to communicate with the walkie-talkies. RF transmitters could have been set up in proximity to Hezbollah's strongholds, allowing the attackers to send a detonation signal over the same frequencies used by the walkie-talkies. The microcontrollers inside the devices would have been programmed to recognize the specific frequency of the signal and trigger the detonators when the signal was received. Alternatively, a more sophisticated method might have involved using satellite communication to transmit the detonation signal. This would have allowed the attackers to trigger the explosions from a safe distance, without the need for physical RF transmitters in the region. As with the pagers, geofencing technology could have been employed to ensure that the explosives only detonated in specific areas. The attackers likely took great care to ensure that the walkie-talkies would explode only when they were being used by Hezbollah operatives, minimizing the risk of collateral damage. In conclusion, the operation to detonate thousands of pagers and walkie-talkies in Lebanon was a masterclass in technological warfare. By infiltrating the supply chain, embedding explosives in communication devices, and executing a coordinated remote detonation, the attackers demonstrated an extraordinary level of technological prowess. From microcontrollers and GSM modules to geofencing and RF signals, this operation combined multiple technologies in a way that had never been seen before. It highlights the growing importance of understanding how everyday devices can be weaponized and used for covert operations in modern warfare. This incident serves as a stark reminder of how technology, even low-tech devices like pagers and walkie-talkies, can be manipulated for destructive purposes. As technology continues to advance, so too will the tactics used in conflicts around the world.